10, 9, 8, 7, ignition sequence started. All engines are started. We have ignition, 2, 1, 0. We have a liftoff. We have a liftoff, and it's lighting up the area. It's just like daylight here at Kennedy Space Center as the Saturn V is moving off the pad. It has now cleared the tower.
NASA is now celebrating the 50-year anniversary of Apollo 17. This was the final mission of the Apollo program, and most notably, the last time humans set foot on the moon's surface. The landing site in the Taurus-Littrow Valley was selected so that astronauts could collect samples of the lunar highlands and investigate the volcanic history of the area. So, what was it like to actually be there, and how does this mission connect with NASA's current exploration of the moon and our future plans to return humans to the surface? These questions are best answered by the lunar module pilot for Apollo 17, Jack Schmitt, whose background as a geologist offers unique insight about studying the lunar terrain. For Jack, being on the moon was an unparalleled experience, and future astronauts should expect the same.
Get onto the moon. Seeing this valley of Taurus-Littrow, which is deeper than the Grand Canyon, as a matter of fact, mountains to 6,000 and 7,000 feet above you on either side of the valley, all silhouetted against a black sky with brilliantly illuminated mountain slopes. And the Earth, of course, in one spot above the southern part of the massifs. That all was a new experience.
As I step off at the surface at Taurus-Littrow, we'd like to dedicate the first steps of Apollo 17 to all those who made it possible.
Schmitt and Commander Gene Cernan completed 3 moonwalks on the surface, taking rock samples and deploying scientific instruments. Difficult work considering the surface gravity is only about 1/6 that of Earth's.
What are you working on, Jack? I'm taking a pan. Very good. I'm coming right now. I bet you $1 to donut that you don't get a TGE reading.
Yeah, Gene, if it's easy enough to take it off, why don't you take it off the rover and we'll try and level it and the stuff.
Oh, come on. I'm not sure there's any place to put it on the ground level. No. You have to dig a place. Yeah, I'll do it. Okay, it's coming off. Well, I'll set it right up here. It's gonna fall down a hill. You better stomp off a good place. Yep.
The conditions on the moon, however, were also ripe for the astronauts to have a little fun on the surface as well.
I was strolling on the moon one day in a merry, merry month of December. No, May's the month. May, that's right. May is the year of the month. Go ahead. Oh, there. Poor little head. Let me throw the hammer. Okay? Let me throw the hammer. Please. It's all yours. You got the You deserve it. A hammer thrower, you're a geologist, you ought to be able to throw it. You ready? Go ahead. You ready for this? Ready for this? Yeah. Don't hit the lamp. Or the out step. Look at that. Look at that. Look at that. Beautiful. Looked like it was going 1,000,000 miles, but it really didn't. Didn't it?
The crew managed to gather around 245 pounds of moon rocks and dust samples during their EVAs. It was an impressive collection for scientific analysis back on Earth.
Let's see if I can't crack the corner and get that contact.
The quality and diversity of the Apollo sample collection is just remarkable, absolutely remarkable, and it's a gift that keeps on giving. The researchers continue to go back to these samples. New analytical technology comes along where you can apply new techniques, get more higher resolution information, and that...
Over 3 decades after Apollo 17, NASA launched the Lunar Reconnaissance Orbiter in 2009. The scientific instruments aboard this robotic spacecraft collect a wide variety of scientific data on the moon's environment, including surface and subsurface properties. And since LRO has now been in operation for over 13 years, it has provided a treasure trove of new information about the moon, as well as the capacity to help scientists reinterpret older data and answer scientific questions that had been lingering from the days of Apollo 17. One such case involved the debate over the origins of a light-colored mantle seen at the base of the South Massif in Taurus Littrow. LRO imagery provided a key discovery that enabled scientists to put together the many pieces of the puzzle.
One is clear that there was an older, slightly darker avalanche partially underlying the light-colored light mantle avalanche. And that immediately brought into question whether or not the light mantle avalanche, as people had thought, was triggered by secondary material thrown from the crater Tycho, some 2,000 kilometers to the southwest. It would seem, not impossible, but it would seem to be very coincidental to have two avalanches, one of which was triggered by those impacts. And that in turn, the more we began to understand the Lee-Lincoln Scarp, and that it was indeed, as a result of other LRO analyses elsewhere on the moon, that it was indeed a thrust fault scarp, then you start to think, well, maybe these are being triggered by seismic activity, moonquakes. Clearly, LRO imagery and other sensor data has made a great difference in our ability to augment the interpretation of the geology of the Valley of Taurus Littrow.
As the LRO mission continues enhancing our ability to interpret Apollo-era data, while also collecting new information about the lunar terrain, Jack sees a clear roadmap for the future exploration of the moon and where we should go next.
It's apparent to me that based on just general considerations, as well as the magnificent imagery coming from the Lunar Reconnaissance Orbiter camera, that South Pole Aiken is clearly the place you'd like to have an extended human presence for exploration. With all this new knowledge, I think South Pole Aiken becomes a much higher priority for the next human mission to the moon.
Sure enough, NASA has recently announced that the Artemis missions, which will eventually have humans returning to the lunar surface, will focus on the moon's south pole. In fact, the 13 landing sites currently under consideration sit within the South Pole Aiken Basin, or on its rim. Data shows the presence of water ice in some of the permanently shadowed regions, a discovery that is crucial for understanding the geologic history of the moon, as well as helping establish a sustained human presence there in the future. Overall, the 50th anniversary of Apollo 17 reminds us that this mission was a crucial stepping stone in the history of lunar science, laying the groundwork for missions like LRO, which in turn help open the door on a new era of human exploration with Artemis. And while these missions may be separated by decades of time, they all interconnect with the central premise and understanding of how the moon is the cornerstone to understanding our universe. It allows us to reflect on all the moments, big and small, that led to the success of that historic mission. For Jack, it's a time to reflect on those days, months, and years spent out in the field preparing for the duties of an astronaut. And it was during this time training that Jack learned the invaluable scientific lesson that not everything goes exactly as planned.
Well, those field excursions had all of their interesting aspects. One time, I believe it was in Nevada, where getting off the rover, even without a suit, I had slipped on something and fell.